Plato spacecraft. PLAnetary Transits and Oscillations of Stars. Plato, a space telescope under development by the European Space Agency for launch in 2026. The mission goals are to search for planetary transits across up to 1 million stars, and to discover and characterize rocky extrasolar planets around yellow dwarf stars like our Sun, subgiant stars, and red dwarf stars. The emphasis of the mission is on Earth-like planets in the habitable zone around Sun-like stars where water can exist in liquid state. It is the third medium-class mission in ESA Cosmic Vision program and named after the influential Greek philosopher Plato, the founding figure of Western philosophy, science, and mathematics. A secondary objective of the mission is to study stellar oscillations or seismic activity in stars to measure stellar masses and evolution and enabling the precise characterization of the planet host star, including its age. History. Plato was first proposed in 2007 to the European Space Agency ESA by a team of scientists in response to the call for ESA Cosmic Vision 2015-2025 program. The assessment phase was completed during 2009, and in May 2010 it entered the definition phase. Following a call for missions in July 2010, ESA selected in February 2011 4 candidates for a medium-class mission M3 mission for a launch opportunity in 2024. Plato was announced on 19 February 2014 as the selected M3 class science mission for implementation as part of its Cosmic Vision program. Other competing concepts that were studied included the 4 candidate missions ECHO, Loft, Marco Polo RNST Quest. In January 2015, ESA selected Thales Alenia Space Airbus DS and OHV System AG to conduct 3 parallel phase bone studies to define the system and subsystem aspects of Plato, which were completed in 2016. On 20 June 2017, ESA has adopted Plato in the science program, which means that the mission can move from a blueprint into construction. In the coming months, industry will be asked to make bids to supply the spacecraft platform. The Plato Mission Consortium, that is responsible for the payload and for major contributions to the science operations, is led by Prof. Heike Rauer at the German Aerospace Center DLR Institute of Planetary Research. The design of the telescope optical units is made by an international team from Italy, Switzerland, and Sweden, and coordinated by Roberto Ragazzoni at INAF Istituto Nazionale di Astrofisica Osservatorio Astronomico di Padova. The telescope optical unit development is funded by the Italian Space Agency, the Swiss Space Office, and the Swedish National Space Board. Plato is an acronym, but also the name of a philosopher in classical Greece. Plato 428–348 BC was looking for a physical law accounting for the orbit of planets, errant stars, and able to satisfy the philosopher's needs for uniformity and regularity. Objective. The objective is detection of terrestrial exoplanets up to the habitable zone of solar-type stars and characterization of their bulk properties needed to determine their habitability. To achieve this objective, the mission has these goals. Discover and characterize many nearby exoplanetary systems, with a precision in the determination of the planet radius up to 3%, of stellar age up to 10%, and of the planet mass up to 10%, the latter in combination with on-ground radial velocity measurements. Detect and characterize Earth-sized planets and super-Earths in the habitable zone around solar-type stars. Discover and characterize many exoplanetary systems to study their typical architectures and dependencies on the properties of their host stars and the environment. Measure stellar oscillations to study the internal structure of stars and how it evolves with age. Identify good targets for spectroscopic measurements investigate exoplanet atmospheres, Plato will differ from the Corot and Kepler space telescopes that it will study relatively bright stars between magnitudes 4 and 11, enabling a more accurate determination of planetary parameters and making it easier to confirm planets and measure their masses using follow-up radial velocity measurements on ground-based telescopes. Its dwell time will be longer than that of the TESS NASA mission, making it sensitive to longer period planets. Optics. The Plato payload is based on a multi-telescope approach, involving 26 cameras in total, a set of 24 normal cameras organized in 4 groups, and a set of 2 fast cameras for bright stars. The 24 normal cameras work at a readout cadence of 25 seconds and monitor stars fainter than apparent magnitude 8. The 2 fast cameras work at a cadence of 5 seconds to observe stars between magnitude 4 to 8. The cameras are refracting telescopes using 6 lenses. Each camera has an 1100 dictwo field and a 120 mm lens diameter. Each camera is equipped with its own CCD staring array, consisting of 4 CCD of 4510 x 4510 pixels. The 24 normal cameras will be arranged in 4 groups of 6 cameras with their lines of sight offset by a 9.2 angle from the +z PLM axis. This particular configuration allows surveying an instantaneous field of view of about 2250 dictwo per pointing. The Space Observatory will rotate around the mean line of sight once per year, delivering a continuous survey of the same region of the sky. Launch. The Space Observatory is planned to launch in 2026 to the Sun-Earth L2 Lagrangian point. Data release schedule. The public release of photometric data, including light curves and high-level science products for each quarter, will be made after 6 months and no later than 1 year after the end of their validation period. The data are processed by quarters because this is the duration between each 90-degree rotation of the spacecraft. For the first quarter of observations, 6 months are required for data validation and pipeline updates. For the following quarters, 3 months will be needed. A small number of stars, no more than 2,000 stars out of 250,000, will have proprietary status, meaning the data will only be accessible to members of the Plato mission consortium for a given time period. They will be selected using the first 3 months of Plato observations for each field. The proprietary period is limited to 6 months after the completion of the ground-based observations or the end of the mission archival phase launch date +7.5 years, whichever comes first.